Good day. Welcome to the Exedoc webinar on evaluating manufacturer certificates and failure rates. Thank you all for attending. We hope very much you'll find your time well spent. I just wanted to comment that everyone registered for the course will have an opportunity to get a set of these slides, and the entire webinar is being recorded. So you can look at it again later if you wish. Please do not hesitate to type in a question at any time. I will try hard to notice all of them and answer them as quickly as possible. Well, good morning. We're going to talk about certificates today. And why talk about evaluating certificates? I mean, you got a certificate in your hand. That's all you need. Go design. Well, not quite. There's some gotchas with everyone's certificates. And we're going to talk about the three things you need to check when trying to verify a given safety function design. We'll talk about selecting the products for those designs, and we'll talk about the criteria that Exida uses when we are doing CIF verification on systems level jobs, and when we accept and when we reject a certificate. My name is Bill Goebel. I've been around a long time. I've been at Exida for almost 20 years now, and most of my experience prior to that was with a manufacturer, More Products Company, which became Siemens. I have become a real believer in the probabilistic analysis method, and I like to tell everyone when I get asked a question, let the numbers answer the question. I work for Exida. We consider ourselves a very customer-focused company. We deliver a set of powerful lifecycle tools to help people achieve higher levels of safety and optimal safety designs. We have a thorough certification and assessment scheme, which hopefully helps manufacturers develop much better products, and we have lifecycle services to deploy throughout the safety life cycles. We measure our success by market share, where in the certification business, we were quite pleased to discover that Exida is doing the majority of process industry functional safety certifications worldwide. Our employees own the company. There is no outside investor. All of our people, most all of our people have a stake in the company, and we keep key statistics about our size and our achievements. We're happy about it. Exida has grown to become a global company with offices around the world. Our tool suite is called Excelencia. It is a suite based on an intelligent data core that allows you to share information between different tasks. Why? You reduce mistakes and you save money. Kind of hard not to like both of those things. I'm very proud that Exida has authored most of the industry references for functional safety, including this new book in the middle. I don't know if you've seen it yet. It's coming out from ISA. Should be available any week now. Today, we're going to talk about evaluating certificates. And I'm very serious. You really should challenge any certification body, including Exida, if there's something you feel is not right. We'll cover the three verification issues. I'll talk about manufacturer certificates and how they should help you. We're going to talk about the failure data. What is a calibrated FMEDA? Ultimately, I want to explain how all reliability data must come from field failure data. We'll explain and show you the SIL-Safe data website and how you can use it to check data validity, and give you a bunch of example certificates good ones and bad ones from all certification bodies. Don't forget, if I say something you challenge, type it up. If I say something you don't understand, please type in a question. There are three things I do when I want to determine if a design meets a given SIL level. You show me a design. Let's go process industry. It's got a pressure sensor. It's got a logic solver. It's got a remote actuated valve with some solenoids, a quick release, quick exhaust valve, an actuator, and let's say it has a nice triple offset butterfly valve. I need to check to see if all of the components used in that design have sufficient systematic capability. Now that's a term that was actually only defined in 61508-2010. Before that, everyone in the industry was using the term SIL capability, and you still see some of the old terms. You can also, as it's explained far more clearly in the 2016 version of 61511, you can also use prior use justification to determine systematic capability. Second thing, we do have to calculate a PFH or a PFD average based on the failure rates and about 8 other parameters for a given site and a given installation. We calculate a PFD average based on these 9 parameters and determine if it's within the range for a given SIL level. And then we check architecture constraints using either the Route 1H 61508 tables or 61508 Route 2H, which has been adopted completely in the 61511 2016 standard. I like to call them the 3 barriers, the 3 hurdles. Check all 3 of them. Question, do you have the presentation written? Slides are available and a recording will be made, but we don't have it written up in text. Not a bad idea. Let's talk about systematic capability. Are these parts good enough? Do they have sufficient quality? And it's not just manufacturing quality, it's design quality. But before we even get into that, I definitely want to say something important here. You must check to make sure anything you choose, any product you choose for a safety function, will perform all the needed functions, that the device is rated for the expected operating environment and the process chemistry. And you must check to make sure the safety function implementation has been done according to the device safety manuals. It doesn't do you any good to have a certified product if it doesn't do the job that needs to be done. I hope that's totally obvious, but I'd like to say it anyway, just to make sure you understand. Now we'll get into the second part of systematic capability, safety integrity. And of course, prior use justification can be used to verify safety and systematic integrity. I don't think that was well explained in the original version of 61511, but the new version does an excellent job at explaining that much better than before. But what happens if you want to use a product that you don't have a lot of experience with? Well, functional safety certification is the preferred path. And of course, for many people, it's the preferred path anyway, because they don't want to document all of the experience and field failures they've collected and so forth. So a lot of people are using functional safety certification to determine systematic capability. Manufacturer certificates should provide you with a lot of very useful information. The manufacturer's certificate should provide you with a SIL level for systematic capability. 61508 calls that SC. SC3 means it's SIL capable. And if you're designing a SIL3 function, you need SIL3 capable devices, even if they're redundant. I know that's a little controversial, and we have a whole webinar on that, so I won't get into it today. Certificates should provide you with at least example failure rate data, and you will find this data on this, usually not on the front page, but usually on a second or third page of any given certificate. A certificate should explain to you architecture constraint type. There's type A and type B, and you need to know what they are. And you need to know if it's Route 2H qualified and how that was determined. Or you can use the 61511 chart and not worry too much about what's on the certificate. And of course, lastly, there really needs to be a statement of compliance. That's important because many certificates are made for things other than functional safety. And we're looking for functional safety certificates using IEC 61508 or one of the derived family standards. So you have a certificate given to you by the salesman of some new company that wants to sell you a product. How do you evaluate this certificate? Is it even valid? Why would I even say that? Well, some aren't. And you'll see the criteria we use. You'll see the criteria that I use. Check the expiration date. Has the certificate expired? I'll explain a little more later about what that really might mean. Check to see the accreditation body logo. If a certification body is accredited and audited by the national accreditation body, if they are using an accredited location and they are following their accredited procedures, they're allowed to use the AB logo. Is there a 61508 requirement statement? In other words, is this certificate for functional safety or something else? That's important. Do you have an experienced and credible organization? I am proud that Automation Research Corporation Advisory Group found that Exida is doing a significant majority of all the certifications in the process industry worldwide. And lastly, is this certificate a forgery? You might say, oh my God, I never thought of that. Well, I will readily admit that, to my knowledge, it does not happen often. But it has happened. Of course, forgeries of Exida certificates I will know about because those who suspect forgery contact us and even send us copies of the forged certificates. But how do you find out if a certificate has been forged? Well, some certification bodies maintain certificate lists on their website. At Exida, it's the Safety Automation Equipment List, and it's part of the Exida website, or you can look at it directly with the URL www.sael-online.com. On our website, we will list Exida and all other certificates from competitors if the manufacturer gives us permission to list them. For most TUV certificates, I have found two websites, the Certipedia.com, managed by TÜV Rheinland, and a Certificate Finder, managed by TÜV Süd America. And I've used both of these when I was searching for a product I'm not familiar with to check the validity of the certificate. Why an expiration date? Well, as you can easily imagine, manufacturers make design changes. Parts become obsolete. New materials become available. Cost-saving innovations are discovered. Products change. You think you've had a Rosemount 3051 and you've used them for years and years? Let me ask you, what revision? Products change. Because of that, of course, a good certification body will perform what are known in the accreditation circles as surveillance audits. The objective is to check if a product is, quote, still safe. At Exedoc, our policy is to check all design changes made since the last surveillance audit or since the original certification, including material changes and component changes, and make certain that every change has been properly documented. Documentation is kept up to date. Testing has been properly repeated, and the product is just as safe as it was during the initial certification. We check field failure records and warranty returns to make certain that there's no unexpected design issues. And lastly, we check any design and test process changes. Now, in fact, Exedoc used to use the term expiration date, but it did cause some confusion because someone would buy a product and they see the expiration date of December 1st, 2019, and say, well, I just installed this. Does that mean I have to rip it out after December 1st, 2019? Well, no. A product purchased with a valid certification date remains, the certificate and the certification remains valid for the life of that product. But what it does mean is the manufacturer is not to keep selling that product as a certified, newly manufactured product as a certified product. Anyway, we changed the name to surveillance audit. I see a question. How regularly are these audits conducted? That policy varies from certification body to certification body. At Exedoc, the surveillance period might be 1 year, 2 years, or 3 years, depending on the rate of change in the design and the quality procedures in place at the manufacturer. In other words, manufacturers who have a history of doing a great job, they get it every 3 years. Others have a shorter time period. Thanks for asking. That's what expiration date is about. The product originally certified may not be safe after several years, and certificates should have expiration dates or at least the warning of when the next surveillance audit is due. Accreditation body logos. I mean, who really cares about this? Well, the fact is, as I mentioned before, certification bodies are allowed to use the logo if the certificate is done in one of the accredited locations. In other words, within a corporation, all locations are not accredited. And if the certificate is done by audited procedures. Some companies choose not to follow their accredited procedures, and they are not allowed to use the AB logo. But it is very common to see it. You can see here clips from a TÜV Süd certificate with the DAX logo, the accreditation body out of Germany, a TÜV Nord certificate with the DAX logo, a CIRA certificate with the UCAS logo, and the Exedoc certificate with the ANSI logo. Another question came in. Thank you. Thank you for the questions. If a certificate is issued to a particular model like, that's a good question, a particular model like Emerson 3051, does it apply to all products? The answer is no. The specific variations, I don't want to claim to be an expert on model numbers in other companies, but I see a lot of different models of 3051, and therefore you will see additional model numbers on Emerson certificates explaining exactly which models the certificate applies to. And some of our people even have been confused a little bit in the past by that, but the fact is, in my opinion, Emerson does an excellent job explaining all that. So I'll get back to the accreditation body logo. What's it really mean? The accreditation body logo shows a level of quality and credibility. It's something that really should give you confidence in the certificate. We got to check failure rate data. Where did it come from? Is it valid? Is it bogus? And this is terribly controversial subject, of course. Where does the failure rate data come from? And how does this reconcile with the fact that reliability engineers have known for decades that all realistic failure rate data must come from quality field failure data? That's one of the first things I learned in my first reliability engineering course several decades ago. I asked, where do I get the failure rate data come from? Is this just theoretical mumbo jumbo, or is this real? And of course, decades ago, there were not good failure rate data for many things. Vacuum tubes, yep, that was pretty easy, but we dropped vacuum tubes even before I got in college. Anyway, what do manufacturers do? If they don't have, where does manufacturers get field failure data? Well, they do have some. They collect field return information, and it is a valuable source of data. However, there are significant limits to its usage because not all returns are failures. Not all returns are counted, as many are marked no problem found on the incoming inspection. Not all failures are returned to the manufacturer, and that's probably the biggest variable of all. And the manufacturer does not know actual operating hours. Therefore, it's really hard to come up with a failure rate from warranty or even non-warranty field return information. The best you can do is create an upper bound and lower bound. And that's tough. Unfortunately, some manufacturers make some very optimistic assumptions and give you the highest possible or the lowest possible failure rate, the best possible number they can. And quite frankly, I was trained to do that when I worked for a manufacturer. So, I don't know. I wish I knew more back then. Another question. I have some failure rates, including MTBF and other data. How many hours of operation are required to generate an MTBF? Well, the more you have, the more certain the answer is, and there are ways of calculating, taking into account uncertainty, but it's a little bit out of the realm of this discussion right now. The bottom line at Exida is we, as I'll show you in a moment, we feel we need a lot of hours, and I'll show you what I mean by that. Manufacturers also have failure rate prediction techniques where you predict a failure rate based on either test results or design strength analysis. Two common types are called the B10 and the FMEDA. Now, B10 is based on cycle testing. And the assumption is that all failures occur due to premature wear out, but that's only applicable when a product is rapidly moving, like in high-speed machine applications. The bottom line is there are a lot of failure modes that become very significant whenever a product does not move frequently, like stiction cold welding and corrosion binding. And most of these failures are dangerous in a process industry application. And therefore, we need to be very clear that B10 is not suitable for process industry applications. Now here's a certificate distributed by a manufacturer which very much appears to use cycle testing. Let's take a closer look. In the upper table, it's very clear that a cycle rate of 2,000 cycles per year was used and calculated a failure rate of 145 fits. A fit is failures per billion hours. And there is a method for that. The best documentation I know is in the ISO 13849 standard. 145 fits, okay. Then the next table shows when the failure rate is when the cycle rate is 1 cycle per year, the failure rate is 0.07 fits. All right, it's very clear to me how that number was obtained. I take 145 divided by 2,000, the number of cycles, because I'm converting from 2,000 cycles per year to 1 cycle per year. And you get a wonderfully low failure rate of 0.725 fits per year. I mean, 0.725 fits per billion hours. That has got to be the world's most wonderful solenoid valve. It basically never fails. Unfortunately, that's the opposite direction of realistic failure rates and does not account for the real failure modes of process industry applications. So we don't want to be using failure rates like this in a SIL calculation. You will under-design. This is dangerous. FMEDA is a study of design strength. By looking at every component, the stress factors on that component, the relevant stress factors, we can determine the failure rates, failure modes, useful life, and proof test coverage of a device. That really requires what we call the calibrated FMEDA, and that's where the field failure data comes in. Real field data, failure rate data, and published failure rate data is compared to FMEDA results. And if those results don't match, you have to explain why and update component failure rates or create new parts into a component database. This is a closed loop comparison-based system, which we call comprehensive analysis. And the end results, by using a combination of field failure estimated results and FMEDA predicted results, we are getting very realistic failure rate data. And that failure rate data can then be used to establish upper-lower bounds by doing a plus or minus 2 sigma, 3 sigma uncertainty analysis. Back to your question about how many hours. At Exedoc, we have collected over 350 billion unit hours of field failure data from the process industries, from manufacturer field return studies, industry databases, and specific end-user field failure data studies. We take that data and we build scatter diagrams like the one on the right-hand side of your screen, where we have results from FMEDA results from 35 different pressure transmitters in these blue diamond dots. The average of all of those, which represents something you can compare to field failure results, is right there in that big green dot in the middle. And we compare that with the Dow field data and the exida field failure data, for example. And you can see the FMEDA data is a little high. And as a direct result of that, we did some adjustments on the component failure rates for the future after this study was done. But FMEDA results should be somewhat pessimistic because that's safe. We've been doing these comparisons for almost 20 years now and found that we've gotten to the point where the calibrated FMEDA results are very realistic of process industry applications. Even for mechanical parts, you can see a bunch of blue dots that represent a sampling of solenoid valve FMEDAs, and it's very clear that spool valves have much higher failure rate than poppet valves, but the average, which is comparable to field failure data, because field failure data aggregates multiple manufacturers and model numbers. The FMEDA average was kind of high compared to the exida-derived number, a pipeline company field data set, and the Dow field data set. And that's the way it should be. And that's good. Unfortunately, the cycle testing results are way, way below the real field failure test results, and that's just all the more reason why we really should not be using them. The statistical analysis of the FMEDA results can be used to provide upper bound and lower bound limits per a product type. For example, let's draw a line right about 60 fits. That is the SIL-safe data limit for poppet valves. And you can see it's significantly lower than some of the results, but cycle, again, it shows that cycle testing and perhaps manufacturer's warranty return data is really kind of optimistic. And of course, for a spool type solenoid valve, which has a lot more seals and more parts, the lower limit is 450 fits. And this is great because now we have some method of checking failure rate data on certificates. That is what we call silsafedata.com. It does provide upper bound and lower bound failure rates for process industry applications, and a typical chart looks like this for any particular product type. And it's not just triple offset butterfly, but includes multiple applications of close on trip, tight shut off, and open on trip. And you can see the failure rate should really be for triple offset butterfly, close on trip, no tight shut off, should be between 450 and 750 fits. Every design we've analyzed to date falls in that range. Let's look at some certificates. Let's look at this certificate on the left. This certificate came in many months ago, actually. Triple offset butterfly valve manufactured by ISP in Mexico. Quality's pretty poor. That's a suspect. Oh, look, the assessment expired. That's not good. Something about this looks bad. So we're going to check on SAEL online for the butterfly valve list, and there is no ISP certificate on that list. An email came in and we double checked just to make sure we weren't missing something, and it was crystal clear. This certificate is a forgery. And of course, Exida safety function verification people did not accept this particular. Another question came in. I'll get to it at the end. Let's keep looking at a certificate. Now here's one, a certificate of conformity. So I'm going to check expiration date, yeah, there is one down in the about 2/3 the way down in the middle of the certificate. 2018 0331. It's still valid. And is there a statement of compliance? Yes, there is. There's a nice statement of compliance here. Okay, 2 checks, good. Check for, oh, I don't see an accreditation body logo. I wonder if the if this particular location is not accredited. Don't know. But let's check the failure rates. I'm going to go for the highest one on the chart here. I'll close with tight shutoff. 2.85 E to, that's 28.5 fits. Let's check SillSafe data. It's a floating ball valve. It's tight shutoff. The lower bound should be 800 fits. I don't know where that number came from or how it was derived, but it's far, far below the -3 sigma limit from SillSafe data. This certificate was not accepted. It was not accepted for systematic capability, as we're not confident this particular site is accredited, and the failure rates are 80, more than an order of magnitude too low. Not good. Here's another certificate we got. It's called an EC type examination certificate. That's a different name. I'm not used to seeing that. Check the expiration date. Oh, it's still valid. Check for a logo. Oh, there's no accreditation body logo. Not sure what that means, but I'm a little worried. 61508 is not even listed in the standards list. I do see it was done by the machinery group. There's no failure rate data, no indication of type A or B, and no architecture constraints. I'm not saying this is invalid, but it's not useful for 61511 systematic capability. Here's another one, very similar. I do see this is more recent. There is a statement of compliance, and 61508 is included in the list, and there is a statement up to SIL 3. Expiration date is valid. It's still from the machinery group, and there's no failure rate data. No type data. In fact, I can't tell from the description whether it is a type A or a type B, so we're going to have to go find that out. And there's no architecture constraints listed at all. So this does seem to be very machinery oriented. I will tell you, however, that 61508 was listed, and at least with me and many of us here at Exida, Rockwell has a very high quality reputation, and we've done many audits there and discovered it's good. So we decided we would accept this certificate, but we did an inquiry to the manufacturer to obtain the missing information. We will accept this certificate for systematic capability. Since there is no failure rate data, we're going to have to get that, and it's going to have to be credible. Now, that's checking failure rate data for credibility. Yeah. Well, first of all, but the previous certificate is for machinery, and it might very well be that this one is too. But it does say 61508, and the previous one did not. Although it was on the edge. I don't know. The only reason at Exedoc we decided to accept it was because of Rockwell's high quality reputation, at least with us. Another question. Are there any plans to update the SERH generic data? Yeah, there is a relationship between SillSafe data and the generic data set, and we're working on it hard. Fortunately, we're also working on a lot of other stuff, which is good. The business is good. So we're gonna work on it as hard as we can. We hope to have it done by the end of the year. Another question. Please remind me whether we are discussing SU. Oh, that's a good question. SD, DD, or DD. We're talking dangerous failures for type A devices and dangerous undetected for type B devices, and which means DU across the board. Now there is a note at the bottom of the SillSafe data charts explaining that, but I'm glad you asked. Thanks. Same question again. Is the data shown in SillSafe data the summation of all failure rates, safe and dangerous, or dangerous only? And the answer is dangerous only, which is dangerous undetected when there are no diagnostics, and it's total dangerous, when there are no diagnostics, or DU when there is a lot. Another comment or question. Test institute equals a mark of compliance for other test institutes. I don't know what test institute is. This is a method of self-policing as there are no formal testing establishing competency. There is no regulation that ends the value of the standard. Please explain. In the world of functional safety, each country has one or more accreditation bodies, ABs. In the United States, it's ANSI. In Germany, it's DAX. England, it's UCAS. They are all part of the International Accreditation Forum, and they get audited by each other, and there's a system of consistency and competency worldwide. I think it's an excellent system. Unfortunately, it's a pain. It's rough, but that's okay. Okay, in this certificate, the certification has been given by TUV and the body. Certification body is not the same as accreditation body. I have seen two Freundland certificates that do have the DAX logo, and if we're talking about Germany, and this particular certificate that's on the screen right now says Berlin, I expect to see a DAX logo, but I don't see it yet. Now, I want to talk a little bit about manufacturers' self-declarations. Well, we got this one, and it said, will you accept this? Well, there is a statement of compliance, and it does say up to SIL 3, which is like a systematic capability rating. They do talk about architecture constraints, and they claim Route 2H compliance, but there is no date. There's no accreditation body. Of course, the manufacturer is not even a certification body. We don't know if it's type A or type B, although a solenoid valve is pretty obvious. It's type A. There's no specific architecture constraints listed. But the real red flag is, look at this failure rate. The total dangerous failure rate, DD is 0, so total dangerous failure rate is 5 fits. 5 fits. For a spool type solenoid valve, that's far below the SillSafe data of 450. It's almost 2 orders of magnitude too low. I don't know how this data came about, but maybe this is the world's greatest solenoid valve, or maybe the method used to calculate the data is based on manufacturer's warranty data or cycle testing, but in any case, it's not credible. Now, one of the reasons I don't know if I should tell you the story or not. Too late. I started. Exedoc once audited a manufacturer for 61508. They failed very badly. And 3 months later, they were publishing a declaration of conformity signed by their own quality manager. we were bound by non-disclosure to not talk about our failed audit, but the whole experience gave me a very negative feeling about manufacturer self-declarations. So Exedoc would not accept this, although we would if we had a full safety case and did an audit and a calibrated FMEDA were done. Of course, if you do all that, then they basically have a certificate. Here's another certificate of a compliance. I've checked it. There is a statement. Type A is declared, but no failure rate data, no expiration date, no accreditation body logo, no systematic capability, even though this was issued after the 61500. Oh, look, they're using the old version of 61508 up here. Well, quite frankly, given the reputation, Exedoc did accept this certificate with an inquiry to the manufacturer and acceptance of all the missing information. An FMEDA, a calibrated FMEDA was done on the product to generate realistic failure rate data, and Exedoc did accept this certificate for systematic capability purposes after auditing the details. So sometimes they're really marginal, but some of these older ones, especially the ones based on the old standard, you have to give them a little leeway. So what do we do? Do you just get a certificate, check the box, and move on? No. Sorry. That would be nice, actually. But I got these bullet points. If a certificate looks suspicious or with working with an unknown manufacturer, check the certification body website to make sure this isn't a forgery. If you can't find the certificate, send an email to the certification body for verification. If the certificate has expired or the surveillance date is overdue, contact the manufacturer or the certification body to see if the certification has been abandoned. Do you understand what I'm saying? Some manufacturers get a certificate and then decide they want to make changes that might impact the safety, and they allow their certificate to expire. They abandon the certification. Exedoc will, quote, withdraw the certificate. But it's really bad news when the salesmen keep using the old expired certificate to sell the product. It happens. If the certificate does not have an accreditation body logo, contact the manufacturer and see if they have an updated certificate. The concept of using the accreditation body logos really only started about 10 years ago. Verify the certificate has a statement of compliance. Maybe it's not suitable for process industries, or maybe it's just electrical safety, hazardous areas and so forth. Check to see if any failure rates provided. Check any failure rates provided against your company's failure rate database or silsafedata.com. And remember, a good SIF design needs more than just certified products. You can't just buy a bunch of certified products, hook them up, and meet SIL levels. You have to jump all 3 hurdles. You have to meet all 3 barriers. But having a valid certified products helps you meet all 3 barriers and provides a good foundation for a good design. Just checking to see. I don't see any more questions. If you have any questions at any time, please don't hesitate to email. I may not answer right away. I'll be happy to. It's an asynchronous mechanism, and I answer them in the evenings or weekend. check out the Exida website. We have many reference material or many books written in the exida.com web store. We have a pile of white papers and YouTube videos of all of our webinars. For those of you who would like to learn more, Exida is now giving, on average, 2 courses a week everywhere in the world. Most of these courses are doing very well, and most of our customers are quite pleased with the results. Okay, another question popped in. Oh, it's a long one. I have an interesting situation. The device has been assessed to SC2 with HFT1 by UCAS and DAS. Fine. Those are good check boxes. However, manufacturer gives an SC1 and no mention of SC2. I don't like that. That's systematic capability is an absolute limit in my mind, and there are many good reasons for that, mostly having to do with common cause failure in a redundant system. And we have a whole webinar on that subject. Check out the YouTube. Anyway, if I were given a certificate that says systematic capability of SIL 1, I would not use the product in a SIL 2 design, even with HFT equals 1, except in one case, if you have diverse redundant designs. It goes on, the certificate was performed against a furnace standard, but not against 6.1. Most of the furnace standards have a substantially reduced subset of requirements, not nearly as tough as IEC 61508. So it's no wonder SC1 is the rating. Be very careful about that if you wish to claim compliance to 61511 or 61508. If you only want to if you only wish to claim compliance to the furnace standard, that's probably okay. It depends on where you live and what the authority having jurisdiction has to say about that. Another question, is Exida in Canada? Yes, Exida has a corporation and a small staff in Canada, mostly involved in certification. Please send me an email and I'll get you in touch with the right people. Time check, 10:53 on my clock. I just want to say, if you have any more questions, do not hesitate to send an email. Oh, more. Does Exida have an office in India? Yes, Exida does have an office in India. We just started a few last year. Send me an email and I'll get you in touch with them. Is 61508 undergoing any update? Committees are active right now. I am not on any of those committees right now. Exida people are on those committees, but I haven't heard a report from them. I think the target is to give us an update by 2020. But I don't know that, so that's all the information I have. Thanks again for attending. I appreciate your time, and I very much appreciate your questions. If you have any more, do not hesitate to send an email. I mean, I'm criticizing all certification bodies. Even Exida screws up every now and then. Anything that doesn't look right, challenge it. And a good certification body will make it right. Thank you all. Stay tuned for more. Oh, is there an Exida in Colombia? We do have a person in Latin America and a corporation out of Mexico. If you need the contact name of our person in Colombia, send me an email, let me know. Have a great day. Thank you all for attending. Bye-bye.